Hello, everyone. We'll be starting in just a few moments from now. Thank you. Hello, everyone, and welcome to today's webinar. Today's webinar will be dealing with what's new in SolidCAM 2021 with the new SolidCAM Simulator. And this webinar will be given by Anthony Calderone. But before we actually start the webinar, Emil would like to say a few words. So, Emil, you can go ahead. You are unmuted, and I will make you the presenter. Okay, Emil, go ahead.
Hello, everybody. Nice to have you again in one of our important webinars about our extremely fascinating new SolidCAM simulator in our latest version, SolidCAM 2021. The webinar will be provided by two very important people in SolidCAM staff. First, Mark Ferstein, who is one of the major developers in SolidCAM in the last 20 years that he has been with SolidCAM. He is currently working from Vancouver, Canada, but he is doing his utmost effort to get us our best products to the market. He was joined by Anthony Calderone, our SolidCAM US CTO, and he's also the iMachining product co-manager with his brother Chris Calderone. Anthony has been working with CNC since the age of 12 in his father's machine shop. And you can imagine, in all these years, he has met most of our competitors, including our main competitor in the US, Mastercam. And he has also dealt with many customer requests, so he knows what our customers need. The new SolidCAM simulator merges all previous simulation modes into a single environment and takes advantage of today's 64-bit multi-core architecture to increase simulation speed to a great extent. The high-quality rendering of the new simulator gives an amazing simulation graphics, and in addition to all its new customer-centric functions, gives SolidCAM a simulation power that is not available in any other existing CAM system. A major addition that we are now working on to add to the simulator in coming SolidCAM 2021 SP versions is multi-channel simulation. The multi-channel simulation will provide users working on multi-channel CNC machines, both advanced mill turn and Swiss type CNCs, a very fast and useful, friendly simulation tool that will enhance and empower the whole user experience while defining its various operations and doing synchronization between them. So look forward to it and enjoy today's webinar. Anthony, go ahead.
Okay, Emil, thank you very much. Anthony, I will now make you the presenter, and you can go ahead, unmute yourself, and show your screen.
All right, Sydney, can you see my screen? Just to make sure
yes,
everybody's
I can.
looking at it. Okay, great.
And I hear you very well as well.
Awesome, great, thank you. All right, hi everyone. We are, as Emil said, we're excited to present the new SolidCAM simulator today. I will be going an overview over the SolidCAM simulator while also highlighting the new developments in 2021. For everybody who has been watching the webinars done by Michael Vanetsky, he's been showing the new simulator, so I think everybody has seen it in 2021, and the new simulator has been in SolidCAM in a beta form since 2019. So this, I'm kind of like gonna wrap everything up in, let's say, a big overview, and half of it's gonna be about the what's new stuff in 2021, which, as Emil talked about, was the wrapping all the old simulation modes into one. So this is gonna be broken into 7 different parts. I have an introduction to the simulator. I talk about themes, customizing themes, playback control, collision or clash detection, stock and target comparison, and measuring. It's a lot of stuff to go over. I got about 45 minutes. and hopefully I stick on time and I don't go long or I don't talk too fast. So let's start here. So first thing to know is there are two ways to launch the SolidCAM simulator. From inside an operation, if you hold down Control on your keyboard and press the Simulate button, it will launch the SolidCAM simulator. And when doing this way, we are launching the simulation with just that individual operation. The second method is from the CAM tree, you can highlight any number of operations, right click, and go to the SolidCAM simulator. I'm going to maximize it. And so the simulator was meant to be a minimalistic UI. So we have no ribbons or toolbars. You can see we have a high quality rendering, and that places a main focus on the stock, target, fixture, and holders. Going over the UI at the bottom, we have the operation slider bar, and above that, we have our playback controls. We use 3 vertical dots. This is kind of like the 3 dashes you see in cell phones for like menu buttons. This is sometimes referred to as the hamburger menu. And these 3 vertical dots bring up a localized menu for those in that area of the software. In the top right, we have our view cube, and this is a clickable view cube, and as you rotate, it's also changing. Below that, we have the SolidCAM menu cube, and below that, we have the theme menu gear. You'll notice that both of these menus are auto pop-up, so there's no need to right-click on them to pop up the menu. We can just hover our mouse and they pop up. Depending upon the active theme you have activated, you will see the compare stock and target dialog on the left, but this can be dragged to anywhere in the simulation. So it's possible it's in a different spot. And then at the very bottom of the dialog, we have our status bar. And like any status bar, it's going to give you status updates about things going on in the simulation. There is a mode where we can take it out of flyout window. And if we do that, this brings it into the SolidWorks Graphics View, and everything is embedded into it. When we're in this view, there is a special graphical element called the minimize cube, which is over here. And this can also be moved by dragging. When you click on this, it makes a minimized view of the simulation, exposing the original SolidWorks models in your assembly. You can also scroll with your mouse wheel, and it will make the minimized version a little bit bigger. So the idea here is that you can keep this minimized while you're doing things in SolidWorks, measuring, sketching, whatnot. I'm going to switch back to the flyout mode. We'll make it full size again. The simulator also has extensive support for shortcut keys. So first, if we're in flyout mode, we can use similar shortcuts to SolidWorks. This is using the arrow keys. So if we use the arrow keys, we can rotate. This is also done in combination with using the Shift or the Alt key. So if you do Alt, it's rotating about the normal of the view, and Shift is rotating by 90 degrees. Additionally, you can find the other shortcut keys by reading tooltips. So for instance, if you highlight over the playback controls, you can see tooltips, Control Shift right would do single stepping through the simulation. If you go through the menu, you will also see shortcut keys listed on the right-hand side. For me, I am personally using the shortcut keys to hide and show things. So I am hiding and showing the toolpath, hiding and showing the target, or hiding and showing the fixture. And you can see them. You can see here Control T is for toolpath, Control S is for stock, Shift T is for target. The simulation controls are also extremely useful if you like to use them. a thing to note about the SolidCAM simulator is it is designed to run in parallel while you program in SolidCAM. So let me minimize the window. This means that there's no need to exit the simulation or to stop an active simulation from playing if you need to do something else in SolidCAM. So for instance, I could just open up the tool table, we can go make tools, we can make operations, anything we'd like to do in SolidCAM can be active while we have this open. A point of note here, I am doing this on a single monitor because that's the easiest way to do the webinar. Most people, I think at this point, and most of our customers are using dual monitors. So we've really put a lot of focus on this being a dual monitor like interaction. So most customers and most resellers, if you're programming on dual monitors, you would actually take the simulation window and drag that to the second monitor and use it accordingly. And then this way, it's not taking up any of your view over top of SolidWorks or your operations dialog. If you are using a single monitor, you have the flyout, and it's also, this is why we have the non-flyout mode, so it's embedded directly into SolidWorks, so you don't even have another window. The simulator is also making extensive use of multi-core CPUs, and we're doing this to speed up the loading, switching of themes, and also running solid verification, and I'll talk about some of those things as we go along. Okay. Now let's get into themes. And this is a new topic for SolidCAM 2021. So before we do themes, I'll need to move the little panel here. Let me switch cam parts here. So before we go over themes, I want to review the existing simulation modes in SolidCAM. So if I highlight these two operations, and let's bring up the simulation panel. So currently in SolidCAM, we have several different simulation modes. We have host CAD, 2D, which is turning if you're in turning, 3D, solid verify, and machine simulation. For machine simulation, that's a completely different topic, so we're going to exclude that from this comparison. So let's talk about some of these and understand what they do. So in host CAD simulation, we basically have wireframe toolpath embedded into SolidWorks. And in this, we have either solid verification turned on or off, and we also have the ability to have the wireframe toolpath shown. Fixtures and measurement are not supported in this mode. If we switch to solid verify is a nice, clean, simple environment that just does solid material removal, and we can do stock and target comparisons. The fixture is shown, and there is simple measuring, but there is no wireframe toolpath available here. If we switch to our 3D simulation, the 3D simulation is essentially just a target with a tool and wireframe. This was done generally for 3D and 5-axis toolpath. Things to note here is fixtures, stock, measurement, and collision detections are not supported in this mode. I will close this part and switch over to a turning part just so we can go over the turning theme or the turning in simulation mode. So if we launch the simulation and go to turning, in the turning simulation, it is a 2D cross section where we show the stock, the target, and we show the wireframe toolpath. So now that we've reviewed the existing themes, we can go take a look back at SolidCAM themes in the simulator. And I'm going to, for the most part, I'm going to work in the integrated mode here. So this is just so I don't have two dialogues floating on top. So what are themes? So themes are similar to what you're familiar to with other software packages, and also themes that are found in Microsoft Windows. In general, themes are a collection of graphical settings, such as colors, but in the SolidCAM simulator, we also use all available settings in our themes. So what this does is it allows us to match the general functionality of all of our existing simulation modes without any limitation or missing features. And additionally, users can create or copy existing themes to set up the simulation to your own individual needs. So let's go over the themes we currently have in SolidCAM. So if we highlight over the theme gear icon, we have default. Default theme is basically solid verification with the stock shown, the fixture, wireframe toolpath, and it has enhanced rendering. If we switch to solid verify, slow that down. So this is matching basically the colors and behavior of solid verify. Most notable is, let's say, the graphics, and that the wireframe toolpath is turned off. If we switch to 3D simulation, is matching the behavior of 3D simulation, which is basically wireframe toolpath and target being the only visible objects on the screen. I'm going to skip turning for right now. We have a heavy part theme, and heavy part theme is essentially the same as the default theme, except we have certain options turned off to better handle complex and heavy parts that are generally found with HSM or 5-axis toolpath. I will switch over to my turning part so we can just take a look at the turning theme. When we switch to the turning theme, we get a little pop-up that tells us that the turning theme is only supported in flyout window mode. This makes sense as we do our own cross-sectional view and go to a 2D view. As we see in the 2D turning, it is matching almost exactly what we have in the old 2D turning. The main difference here is this is also in the same true 3D environment as the rest of the simulations. I'll switch back to default, bring us back to integrated. And now we will switch back to our milling part, and we will go over customizations and themes. Now I am using, just to mention, I am using a SolidWorks macro to hide and show the models in SolidWorks, and I just have these set up to a shortcut key. So if anybody's wondering how I'm easily hiding and showing the SolidWorks models, I just have a nice shortcut to do that. As I said, most customers are going to be using multi-monitor situations, so I think you would most use will be in the flyout mode. So customizing themes. So we talked about how we have our predefined themes, but one of the most powerful tools is that we can actually customize our themes. There's a few things to understand about themes. First is that each theme has the ability to match any other theme just by changing the settings. And any changes in the current theme is saved for that theme. So for instance, if I set the speed slider to this position, this speed slider position will be saved for the default theme, and switching to the other themes will have its own last remembered position for the speed slider. Now let's say we want to make a couple changes to our existing theme. So if we launch the theme editor, for the default theme, I have a few things I want to do. The first thing I would like to do is I would like to take the stock and add a little bit of transparency to it. And I would like to take the target and I would like to make the target visible. And last, I would like to turn off showing the toolpath. If I accept that and then I simulate, you can now see we have a transparent stock. We have the target visible through it, and we do not have the toolpath shown. 3 simple changes. Another change I would also like to make is for the 3D simulation. So in the 3D simulation, I would like to turn on the fixture. So we go to solid body settings, fixture, turn on the fixture, and now it's visible. Now when we play, we can see the wireframe with the 3D fixture. Now I'm going to do my own complete custom theme. And what I'm going to do is I'm going to copy an existing theme, and I'm going to make my own theme for analyzing toolpath. So I'm going to launch the simulator on just this constant Z toolpath. And what I want to do is I want to copy the 3D simulation theme, and then I'm going to make some changes to it. So we're going to go to the theme editor. On the 3D simulation theme, you can either right click or hit the 3 dots. So we're going to hit right click, say duplicate. This makes a copy of this theme. I'm going to rename it, and let's call this 3D cutting only. And now there's a few things I want to do. First, I want to disable the option that says follow the tool for the toolpath. So what this does is the entire toolpath for that operation will be shown at the entire time, and as opposed to it just following the active position of the tool. The other thing I want to do is underneath the toolpath visual settings, I would like to hide the rapid cuts, and I would also like to hide the linking cuts. And I'm also going to change the line thickness to 1 pixel. Now that I've done this, I'm going to highlight all of the operations, excluding the roughing toolpaths. Relaunch the simulation, and by using the skip operation forward, I am now reviewing operation by operation the toolpath. And what's nice is we can zoom in, and we can go operation by operation, and we only see the toolpath. We're not seeing the links, and we're not seeing the rapid movements. So for me, this is nice for reviewing. So let's say I even want to, I can click anywhere on the toolpath, and I can drop the tool there, and I can do zooming, panning, rotating to get a better view of it. Extremely useful, I think, in 3D when we're trying to understand, where the position of the tool is relative to the part. And in 5-axis, let's say it's even more important there. A nice thing we can also do is if we want to double click on the toolpath, if you double click on the toolpath, it repositions the slider to that spot in time. And then if we press play, the simulation will start playing from that point. We are still simulating the rapid and the linking moves. We just don't have those turned on graphically, so that way we can focus on what the wireframe cutting moves look like. Now let's skip to the next operation here, and we can do a couple things here. Another nice thing is that you can switch between the themes seamlessly. So if I were to switch back to the 3D simulation, you can see when we switch to 3D theme, we see all the rapid moves. So we see rapids, we see the links. So this means you can take the operation slider and go to any point in the toolpath. And if you just want to skip to the 3D cutting only, we switch to it and the simulation is not reset. You're not switching, you're not jumping out of the simulation, you're not losing any settings. We can just seamlessly switch between the themes without losing any status. And this reviews me going over themes. As you saw, there is the theme editor, and as I go along, I'm gonna show a couple other things that we can do with the themes. There's searching and stuff like that to get to the settings a little bit more easier. I am going to switch back to my 2D part, multi-sided, and I am going to go over the playback controls. And this is, let's say, a really big difference to the existing simulations in SolidCAM. Now let's just highlight all of these. So in the previous simulations, we only had playing the simulation forward. There was no backwards playback, and there was only basically one mode of just the tool moving step by step. So if we go over the simulation playback controls, there's a lot to kind of cover in just this little area here. So first we have the playback speed slider. So this is similar to what we had in the old simulation mode. We have a few more positions. And something to note here is we have these red colored positions at the very end. And what this means is when we're on the first positions here, we activate multi-core calculation, and we also slow down the redraw rates. So normally when we're on the other positions, we try to do a smooth animation, which means we are simulating at about 30 frames per second, and we simulate every movement. When we activate these modes, we are going lower. I think we go down to like we can go to a maximum of 1 frame per second. And we also buffer many toolpath points and do parallel or multi-core calculation. For 2.5D parts, turning parts, there's really no meaning to use the red portion here. But if we're doing 3D, HSM, I mean, maybe even some large 3D iMachining toolpaths for sure, the simulation plays much faster here. And we mark them in red, so that way you know you're in multi-core and the simulation will play a bit choppier. So if I just play the simulation, we can see we can change the slider position. And you know what, let me switch back to the default theme. That way we're actually doing, let's say, solid verification. And I will also load my defaults again. So really easy to come into the theme editor. We'll go back to the default settings instead of where I had the stock and transparency turned on. And now we're back to the default settings for that theme. So we have our slider. We can move that to any position we like. As I said, if we're on the fastest theme, and I'll play that again, it's almost instant on a 2D part. So this simulation is a magnitude faster than the existing Solid Verify and the other simulations we had in SolidCAM. So down on the bottom, we have the Playback Ribbon. So these are icons, whatever you would like to refer to it as. So we have recording material. So this is an interesting option in that if we go back to the beginning and turn this option on, this is going to record all of the cuts that we're doing, and it allows us to play backwards. So if we simulate, maybe I'll speed that up a little bit and pause it. So now we have this red bar that appears above the operation slider. This means that all of those moves were recorded and are stored in memory. And now we can actually play the simulation backwards. I'm gonna turn off the toolpath, and I use my shortcut key, Control T. And what's nice is we can actually play backwards, and you can see the material added back. You can even take the slider and go back and forth, and the material is added back and forth. When we are on recording, this is a slower simulation because we're recording every single cut. And it also is taking up a lot of RAM in the computer. So for 2.5D parts, no problem. You'll never have a problem with the RAM in the computer. I think the speed is also just fine for 2D turning multi-sided parts. If you're doing heavy HSM and HSS and 5-axis toolpath, depending upon the number of toolpath points, this can definitely slow up the simulation a lot. And we even put the little warning on the tooltip that it does increase the calculation time. Then we have our operation skip back and forward, which we saw me use in the 3D cutting theme that we used for analyzing. And then we also have step forward and step back. So, and this is a big difference, as I said, from the previous simulation modes, that we can play forward or backwards. And then we have play forward and play backwards. And obviously we have a pause button when it pauses. Now I will turn off the simulation or the recording, and I will click the menu because I want to bring up that there's two modes to simulating in the new simulator. There is a performance mode, which is what we're using currently, and this is similar to the existing simulation that we have in SolidCAM. Basically, this is playing toolpath point by toolpath point, and it's either playing as fast as the CPU can when it's at the highest points, or we add a slight delay to make an animation feel to it. We have machining time mode. So if we click on machining time mode, I will deactivate equal playback. And let me also set rapid override to 100%. So machining time mode is actually playing the toolpath at the real cycle time of the machine. So if we take this first operation, we are simulating an operation that takes 5 minutes and 55 seconds. If I play the simulation, it's at 1x speed, it will complete this operation in 5 minutes and 55 seconds. Obviously, we don't want to wait that long. As we increase the slider, this turns into a factor of the simulation. So basically, we are now playing at 32 times. So this is exactly just like a, playing TV or YouTube video. You have a factor that you can play the speed at. You can also play the speed slower. So at a quarter speed. You can also type in any number here you like. So if you click a number, you can say, I want to play at 100.5 time, and it will play at 100.5 times. This is going to be a huge feature for when we do multi-channel synchronization, and this was honestly developed for multi-channel simulation when we did it. So for this, it's very important, but with multi-channel, obviously we need to do all the timing, and this is going to be a big thing that you'll be able to see all the simulations multi-channeled at the same time, and everything will be moving in real time or at a factor of real time. If the question comes up, no, we are not taking into account acceleration or deceleration of the machine. It is purely just the feed rates of the lines, cutting, and rapid. We do have a rapid feed override option. This is essentially exactly what we have in the CNC at the controller. You can change the rapid feed override to be at a slower feed rate, so that way you can see it better. This is definitely something that's interesting, I would say, with like 2D toolpath or even 3D. I mean, 3D toolpath, it might happen a little bit like 3D roughing. If every time you want to see when the tool is moving across the part, you can set this to 1%. And when you select it, you get a little notification here that the machine time is playing with the rapid override at 1%. I don't have a part set up now for this, but if you are playing in machine time playback and you are playing a heavy toolpath that the CPU cannot keep up with the real cycle time of the machine, this happens especially with 5-axis toolpath. It is very possible you have a 5-axis swarf cut that out at the machine. It might only take, let's say, 10 seconds to do a swarf cut along a tapered wall. In the simulation, the fastest the CPU can calculate it might be 10 seconds. So it's lagging. And what you'll see over here on the right-hand side is if the simulation starts to lag or the CPU can't keep up with the machine, the machining time, you're going to see a little red, you're going to see some red text here, and it's going to say lagging, and it's going to say the amount of seconds. That's just to let you know that the CPU cannot keep up with the real cycle time. There is one very nice option in here called equal playback time. What does equal playback time do? This changes the speed slider not to be an actual factor of the time, like 2x speed or 5x speed. You're actually giving us the time that we want the operation to complete in. So in this case, we have 5 seconds. So if I press play, each operation will start and stop in exactly 5 seconds. This is something useful when you get to the end of your CAM program. So let's say at the end of your CAM program, you're going to have 20, 30, 40, 50 operations. It's going to be a mix of face milling, 2D, eye machining, drill operations, and all of these have a different cycle time. for each operation. And more importantly, they have a very different number of toolpath steps. So I think all of us are familiar that when you play the simulation, at the end, you're always playing with the slider to try and see what's going on. You know, if you have a drilling operation right after an eye machining, you're going to have the speed slider up pretty high because eye machining has lots of toolpath points. Then it's going to hit the drilling operations, and then it's just, there's only a couple moves. It flies through the drilling operations, and you don't catch it in the simulation. So then you're either pausing the simulation, or you're trying to restart it, or you use something like stop on next operation. In this mode of equal playback time, all the operations play at the same time. We default to 10 seconds as the default. I think that's a pretty nice time. You know, if you have 20 operations, you get to simulate each one at exactly 5 seconds. It's pretty nice. This is kind of cool if we go down to, like, let's say the drilling operations. And for the drilling, I think these only do like 1 or 2 holes per piece. So I'll set it to 2 seconds. So each operation in SolidCAM is taking 2 seconds to simulate. And as you see, it's of course, and I guess I forget this sometimes when I'm talking, through the go-to meeting, you don't have the crispness that I see here, but it's really playing very smooth. We play it like 30 frames to 60 frames per second, and you really see the drilling in an accurate way that you've never been able to see in SolidCAM before. I mean, you really see every peck. You can see the reamer really come down nice and slow and retract out. It's a very nice option. Then the other thing we have here is something called stationary tool. So in stationary tool, and maybe I'll do this one outside of in the flyout mode. So when we're in stationary tool, the tool is fixed and the part and fixture are moving. So this can be something that's, let's say, it can be semi-accurate if you're cutting on like a 3-axis machine, because most 3-axis machines, the table is moving and the tool is fixed, except for the Z-axis, but more or less the table is moving the part. This is useful for that. It's also useful for very large parts. You know, some of our customers are doing parts that are several meters or, you know, 100 inches long. And, you know, when you zoom out, you got this tool, you got a really big part in the simulation, and the tool's really tiny, so you can't really see it very well. Being able to zoom in on the tool and activate stationary tool, it keeps that at a nice size, and then the part is just moving around, and you can see it the entire time. Or also multi-sided parts where the tool is moving around and hiding behind other faces. The stationary tool can give you a constant look. And I think that covers all of the modes for the playback. So now I will switch over to doing something for the collision detection. I'm going to switch back into integrated mode for this. And let's do something here. So we want to make a collision, so that way we can show what the collision detection does. Okay, we have 2 operations here. We have this P contour 5, which is cutting this top face here. And then we have this P contour 6, which is cutting this slot. Now, the way we programmed it, I knew we cut the top face first, so we did that tool path first, and then I did the second tool path and started from this level and machined down. Let's say we want to reorder these operations such that the slot is now being done before the top face. And remember something from the beginning, I said the simulation is running in parallel with SolidCAM. This means we can make any changes we want while the simulation is open. So we just reordered these operations while the simulation was open and there was no errors. So I'm gonna relaunch. Of course, we need to relaunch the simulation to get the new timing of the order of the operation. So we relaunch it, and I'll still stick with machine time mode and equal playback, and then we'll play it. All right, so now we see collisions. And what you'll notice is we add these little markers in the operation slider so you can actually see the timing of when those collisions occurred. So if we highlight at the beginning, when you put your mouse over it, you're gonna get a tooltip. And basically this tooltip, I can't move my cursor, but you see it tells you the step number, what things actually collided. In here it was the arbor of the tool and the stock. It gives you the coordinates, and then it also tells you that if you click, you can toggle between the start and the end of the clash or the collision. So let's say we go to one of the second level cuts. Which one am I looking for? Yeah, this guy. So if we click on this one, we can see here, this is a collision between the holder and the stock. If we zoom in, we can see that the holder, because now the tool is too short and we never removed the material, the whole holder is actually colliding, not the arbor where we ran out of flute length. We got now the whole holder colliding. We draw this black border, which is showing the collision intersection. Now, when we have a nice big collision here, like the holder colliding with the stock, you get a really nice big black border that's easy to see. If you were dealing with something that's smaller, like a lot of times you might just have a tiny little part of the arbor hitting a little piece of the material, you're not going to see a big black border. So don't expect to always see this nice big black border, but you will always see this toggle, the marker here for the collision point. And obviously there's a collision point here, but as we know, it's colliding along this entire thing. So there is really no specific collision point. There's lots of collisions, but if you can't see the black border, don't be concerned about it. A lot of times collisions are really tiny. You'll see the yellow collision marker and you can use that. Okay, we can, one last thing I wanted to show is you can turn off the collision detection either from the menu by turning it on or off. You can also ask to stop the playback on the clash. So if I were to restart the simulation, you will pause at every collision. So that way you can pause it and stop it. And if you go into the theme editor, you can see that collision detection is turned on or turned off here and here. And just to make a small little note, if we go to the heavy part, you can see that clash detection is turned off in the heavy part. So I will reorder those back again. And now what I would like to do is I want to go over the stock and target comparison. So here we have the stock and target comparison. This little panel is something you can move around. That way you can reposition it in a nice place. This is similar to the stock and target comparison that we have in Solid Verify. The main differences between the Solid Verify and this one is, I would say, basically two things. One, we auto calculate the values based on the facet tolerance. So there's this little function button here. So some people use different facet tolerances based on how big their parts are. We auto calculate them to be something logical. So this is something you'll never really have to touch. We just do it automatically. The second thing is you can turn on stock and target comparison with the icon. And when you play the simulation, the stock and target comparison is dynamically updating. This, I think, is pretty cool looking. So you'll see as we go and do some of this pocket, you'll see it's updating in real time. Now, this does obviously slow the simulation down a little bit because it's doing more graphics and new checking. So I would not recommend having the stock and comparison on while doing 3D or HSM parts. And we even put a little note in the tooltip that it increases the calculation time. You have your sliders, so you can just change, your colors, what you want to see. If you just want to see what's gouging, what's good, and what's excess, you can just move the sliders. And you can just click on any of the colors and change the color to whatever you like. This is very similar to the existing stock and target comparison. You can turn the stock and target comparison on and off through the through the menu, and also through the theme editor. And let's see, we're at 40 minutes. Okay, I got one last thing I want to go over, which is measuring. So let's see, what do I want to do for measuring? Let's say we do from this operation. Okay. So we have what we call dynamic highlighting and dynamic measuring. For anybody that's familiar with SolidWorks, dynamic highlighting, whenever you put your mouse over something, it is highlighting. What you'll notice here is even though I'm highlighting, and this looks like I'm doing dynamic highlighting in SolidWorks, this is actually dynamic highlighting from the simulation. If I switch to the flyout mode, maybe this shows a little bit better. You'll see this is a very similar effect to what you get in SolidWorks with dynamic highlight. So as you go over lines, edges, faces, vertices, midpoints, you are getting dynamic highlighting. This helps with measuring. So maybe I'll do the measuring in the external window. So what do we get? You can pick and you will get measuring. So if we pick a vertice, you can see down here in the bottom right, we get a measurement label or a measurement window. You can click, and this allows you to copy and paste any of the values. When you put my mouse over it, we have a little tooltip that tells us the data that we get. We get V is for, we get vector information, distance, length, points, angles, and distance to the target. So when we click on a point, we get the XYZ point. If we click on a line, we get the line. If we click on a face, we get the vector of the face and the distance to the origin and the distance also to the target. You can also do measurement between items. So for instance, I can highlight 2 points, and then we get a 3D measurement. We get just as we get in SolidWorks, we get the 3D distance, we get the distance in X, Y, and Z, and you can highlight multiple things this way. So we can highlight between 2 edges. We can highlight between a face and a point. So this is similar to SolidWorks, so you kind of have to experiment with all the things that you can measure, and we will continue to hopefully add more measurement things in here. A special measurement to do is measuring of arcs. And this has a special way to measure arcs where we have to highlight 3 consecutive faces. And this is because in the Solid Verify, everything is triangulated. There is no actual arcs. Everything is faceted data, something similar to an STL. So if I hold down Control, I can highlight 3 consecutive faces. And what this will, you'll know you have an arc because we draw this diameter when yellow. And then you'll see down here, you'll get the vector, and you'll also get the radius, which in this case is 10.1. There is a way to help with that, and this is in the theme editor. So in the theme editor, there is something that's called smooth shading. And here I'm going to show you typing and searching for fields. So if I type smooth, we can see the stock has smooth shading turned on. Pay attention to this radius when I turn this on and off. You see the facets appear. So when smooth shading is on, this is one of the things that makes it look smooth and nice and pretty, is it blends all those facets to make it look more natural. When smooth shading is off, you see the pure facets. This makes it much easier to grab those 3 faces. So if you're on smooth shading, you kind of have to go in there a little bit and see it. And also when smooth shading is off, the dynamic highlight is highlighting just the planar, just a little planar facet. So that also makes it easier to pick. Now let's do some, I think I can just jump to maybe this operation. Yeah, this looks good. Okay, let's do a couple cool measurements. This is stuff that I think is useful out at the CNC. So let's say we want to measure the distance from this arc to this edge, right? This is something important. Maybe you loaded, your parts coming from one setup to another setup. You maybe drilled a hole in one operation and then you faced some edge or something. And before you finish the part, you want to be able to go out to the machine and be like, hey, is my part in the right position? So if you pick this arc or this circle and this edge, you will get down here the center to center distance and also the min and the max. So 11.9 millimeters is the distance from this face to the edge of that circle. And let's say, I mean, in this case, this face is already finished, but if we did a roughing tool path around this outside and there was still, let's say, you know, in millimeters, 100 microns, an inch, maybe there's like 4 thou, you can go out to the machine, caliper it, and get some dimensions before you actually, you know, run the finished tool path. We can also measure between holes. So this is kind of cool. If you measure 3 faces for this one, 3 faces for this one, you're going to get the center to center distance, which is 50 millimeters, and the minimum distance, which is 41.8 and 58.2. Once again, I think this is kind of cool because many times in SolidWorks, the hole is not actually the hole size that you drill with the tool, because, you know, generally in SolidWorks, you'll see the hole is, what, it's 5 millimeters or 1/4 inch, but based on the 2D drawing, we'll either drill it, you know, bigger, smaller. So being able to measure the real updated stock allows you to measure the real distances, center to centers, things like that. You can also measure angles. I think this is maybe not as useful, but some people might have this as a use case where let's say I want to measure the dovetail. So I can see that the dovetail is a 60-degree angle. Helpful, it's there. And one last thing I will note about measuring is something we added to the SolidCAM Simulator, but it's available in other places in the software. So let's go to the setup. So all of the little graphical windows that you see in SolidCAM is using the same simulation toolkit in the background. This is why everything kind of looks similar. And what we have is we have measurements and dynamic highlighting in all these windows. This is really helpful for like the machine preview and for setup. So we can see here that the distance from the top of the stock to the face of our trunnion is 162 millimeters. I know this is something all of us who deal with 5-axis, especially trying to move your part around on the table, you're trying to locate it accurately. Or the nice thing is if you set it up in SolidCAM, you're trying to figure out where are you going to put it on the table, so that way you can you know where the fixture is going to go. So in all of these simulations and all of these preview windows, you can do measuring. The measuring will be enabled in the right-click menu. So when you're in like the machine preview, right-click and activate measuring. If it's not activated, then you're not going to get any dynamic highlighting and you're not going to get any measuring. So you have to have measuring turned on to get that. You know, so you can see even here we can measure the trunnion. It's 1,000 millimeters, and this is for machine setup. This is for in the new toolkit. I mean, it's also, you have it in the machine preview, which is the same as the setup, and you also have it in the tool window as well. So if you want to measure things in the tool window, you can measure distances. Like we can see the distance from the bottom of the HSK collet area to the bottom to the tip of the holder is 54.119 millimeters. And I think, yeah, so 50 minutes, that concludes everything I wanted to say. Maybe it was a lot. There is still probably a lot more with the simulator I could go over, but I think that was hopefully enough to highlight the new stuff in 2021. And as a side note, most of this functionality is also available in SolidCAM 2020 SP4. Naturally, all of the awesome simulation stuff, and maybe I'll just throw up the nice angle head part that Michael was using in his demo. Let's just say we go to the SolidCAM Simulator. So in SolidCAM 2021, we have the ability to define in the new tool table these awesome, cool holders and assemblies. So this is something you're not going to get in 2020, but the main functionality of the themes and the measuring and that type of stuff is available in SolidCAM 2021. And just a nice, really cool thing here, we can see we got a collision with this holder. And this is where I think the simulation is much better and more graphical than the previous ones. You can see the collisions really well, and here we can see that in this part, the tapered part of the tapered part of the tool is colliding with the top wall. And I can, I'll turn off the collision detection and just let it continue playing. And while this is playing, I will take a look and see if we have any questions.
Okay, Anthony, I believe we have like just 3 questions over there. The first one you can ignore because they were just a technical question, but you have 3 questions waiting for you over there.
The panel is quite small. Okay, there we go. That's a little bit better.
Actually, you have a lot.
Yep.
You have a lot.
I do. Okay, I do. Will all the functions in the new simulator also work in the shop floor editor? Yes. Yeah. Yep. Same thing with the shop floor editor. Make sure that you launch the SolidCAM Simulator from while it's loaded in SolidWorks, so that way all the facet models for the stock, target, fixture, holders, and everything is built. So when you launch it in the shop floor editor, even though you don't have SolidWorks, all the models will be loaded. Second question is the playback speed based on the speed we recorded the simulation, or is it playback speed adjustable? So let's see, this was 8:35. I think so. That might have been the time I was talking about the simulation playback. So the playback speed so it depends on the mode. If we're in performance mode, this is just playing step by step, and it's basically just, it's not related to cycle time or any of that, or the speed of the cutting. It's just playing in movements. It's playing as fast or slow. It just basically plays step by step. So in this operation, we have 168 toolpath steps. So it's playing step by step, and that's how the simulation plays. If we are in machining time mode, then this is where we are playing based not on the recorded simulation time. This is based on the actual cycle time. So this operation is supposed to run theoretically in 1 minute and 57 seconds. So this is based on, I mean, if we open up the first P contour 13. So we're running at 1,000, this operation here is running 1,000 millimeters per minute at 800 RPM. And I mean, it's not doing a tremendous amount of toolpath, it's just doing some facing. So, and that operation takes exactly 1 minute and 57 seconds. So the simulation is being played in exactly 1 minute and 57 seconds. If you're on machining time mode and you're playing at 1 time speed. And as I mentioned, if 1 minute and 57 seconds is too long, if you were to change this to 2 times factor, then it will play it in half of 1 minute 57, roughly 58 seconds. And let's see, another question. Doesn't mean this offer. Yeah, okay, so another cycle time question, time mode, I did mention it, but no, we do not take into account the axes acceleration and deceleration. We are just taking into account the pure cycle time. Now it does, and this is important to note, it is based on the calculation time that we use in SolidCAM. So if we, as everyone knows, in the VMID, we have the settings for timing. So in the VMID, we have the timing factors and also the tool change cycle time. So the cycle time that we use in the new simulator is based on the VMID times that get used. And this is also the same cycle time that gets used in the channel synchronization dialog when you do setup sheets. So it's the same time is shared everywhere throughout SolidCAM. So this means drilling operations are probably pretty accurate. Machining toolpaths are generally not as accurate because there's lots of toolpath movements and deceleration. Deceleration is not perfectly, it's not perfect there for the cycle time. So as we know, most machining toolpaths are off by, 5 or 10%. depending upon the machine. You know, some are faster, some are slower. And where do you change the facet tolerance for the beta simulator? So the facet tolerance is the same facet tolerance that's used throughout SolidCAM. So if you have several places that you can change the facet tolerance, and it changes it everywhere. So in the updated stock calculation underneath the settings, you have Solid Verify. So this facet tolerance is used for the new simulator, and it's also used for the existing simulation mode, Solid Verify, Solid Verify in the host CAD. So this is where you would change it from. At the moment, we do not have a direct setting in the SolidCAM simulator to change the facet tolerance. So if you need to change the facet tolerance, the quickest place to do it is from the updated stock tolerance here. Coming from iMachining, I would recommend for everybody not to be changing the facet tolerance, because the default 10 microns is generally, I'm not going to say a requirement, but it is what allows the 3D iMachining toolpaths to be accurate and to not have any false collision warnings in the simulation. Because what we do find on the iMachining side is some people do increase the facet tolerance to a larger value, and then the 3D iMachining toolpath does not actually have collisions in it with the stock during the reposition, but when you go to the Solid Verify, it can give false collision detections because the tool is faceted very large, and then the updated stock is also faceted very large. So putting my hat on from the iMachining side, try not to change the updated stock tolerance. With the default is a good value. Of course, I understand that some people have big parts and you might have to change it, but we've done a lot of work as well to all the updated stock. Everything runs in parallel, multi-core calculations. So it is much, much, much faster. The updated stocks and everything are much faster than it was several years ago. When measuring, are the DIMs, man, there actually are a lot of questions in here. Are the dimensions absolute on the Mac position? Yes, they are. All dimensions are based off of Mac 1, position 1. Would it be useful if we had a filter for edges? Yeah, maybe. I mean, in the end, we don't have all the power to do all of the awesome filtering and selections and measurements that SolidWorks does. So it's an awesome suggestion. Maybe we can try it. We have so many things that people want, especially multi-channel simulation now, that filtering for the edges, while it's an awesome idea, I think it's actually really, really cool. It's not something I think we could tackle now, but we definitely is something we could do in the future. Are you clicking on the surfaces, or do you need shift or control? When you do measurements, you just need to click on the surface. If you're highlighting multiple features, like if you want to do point to point, or you want to highlight multiple faces, you have to hold down control. So, and this is the same in SolidWorks, right? So if we click face by face, you get face by face. If I click two faces, then then SolidWorks will start giving you down here your dimensions between those things. Can the simulation be exported as a video file? Not currently. I suppose that is something that could always be added, but no, there's not. Like, in machine simulation, we have we have the presentation mode. We do not currently have that for the simulator. And I don't believe we have an option for the auto repeat. I do know we use that for trade shows and stuff. So that is actually I think that's a pretty easy option to implement, is the auto repeat. We might even have an option, and I forget, but I'll check into that. The mill-turn webinar, mill-turn machines being done, the screw thread was not shown. I wanted to know if the new simulates the threads, and you will see the threads of this. Threading and turning, yes, we will show, if I remember correctly. So there's two ways of showing threading. You can either show real threads, or you show like emulated threads, kind of like SolidWorks does. So I think at the moment we show real threads. The downside to real threads is it is computational. It's so heavy for the computation. It's not even funny. I mean, it is doing helical threads in solid Boolean mathematics even in SolidWorks, I think for anybody that's ever tried modeling a thread in SolidWorks, draw a helix, draw a thread, revolve or cut a long curve, it really increases the memory and really decreases the speed. So I think at the moment, I do think we show threads. I think there has been talk amongst us not to show the threads or to have an option to do just, fake threads to speed it up, because I do think when we do turning threads, it really slows it down. If the operator changes the operation order, how do they know to close the simulation or to show the update simulation? There is nothing to reflect that the user is making changes in the CAM tree order. Since the simulator is running truly in parallel, meaning it does not do any interfacing with SolidCAM. This is how the new simulator is able to completely run while you're creating new tool paths. You can even go into SolidCAM and delete the tools and the operations that are active in the simulation, and the simulation doesn't affect it. It's completely like its own isolated like application toolkit type of thing. When you launch a simulation, all the data is prepared, all the things given to it, and there is no more communicating back to SolidCAM for anything. No toolpath links, no tool information, nothing. So there is at the moment, there is no way for the user to know. He just has to, as you're programming a part, if you delete the operation, if you want to simulate the new things you've done in SolidCAM, you do that. If you're, and from my side, I think it's kind of one of the neat things here is that you can still maintain your old simulation session while you're making changes, because you might not like those changes, because you can still jump to the old simulations and see the result of your new changes and still have the old one set up in the SolidCAM simulator. In the future, there will be a way to be able to update automatically from SolidCAM. So it's something that will be restrictive, because obviously if you're in the middle of adding operations, deleting, or doing something, we can't just get the new operation list, but there will be a way to do that and to be able to get the new operations into the simulator. We've also talked about maybe even adding a little CAM tree, so that way you can deselect or reselect either the operations in it or outside of it. The new STL holders that is in the new version, it's possible, and are they recognized for collision control? Yes, absolutely, Fabio. Yes, this is you know what? While it might take a second, I think it's an awesome thing to see here that in, what operation is it? I think it's this one. Yeah. No, it's not this one. One of these in the STL holder, the coolant line actually hits the simulator, or actually hits the stock. Let's see which one it is. Now, I'm lying. It's one of I was playing with this part before, and one of these does actually hit. But yes, the short answer is yes. The whole STL holder is there we go, collision detection. It's right here. So if we put the tooltip on, you can see that the coolant nozzle for the right angle head is colliding, and we give you the collision warnings. Can the simulation result be exported to a step or STL file? No, not at least not directly from the simulator. The only way to you have to use save updated stock from the CAM tree. I don't remember. I thought there was. You can also save to STL from the stock icon window. So if you wanted to, for instance, save the updated stock from, let's say, this operation here, you can drag that and do save to STL. The updated stock is the exact same model that you are getting here. So there's no difference. You're going to get the same result, but there is no way to save it out at the moment. I think I got through all the questions. Yes, it is.
Yes, you did, Anthony. First of all, phenomenal webinar. Thank you very, very much. It is this tool, the new simulation is a perfect tool. And exactly what every machinist is really looking for when they're looking for in simulation, to get every possible detail, so that when they get to the machine, they don't get those crashes that they, oops, why didn't I see it in simulation? So this is really phenomenal tool, and very well done. Again, everyone, this has been recorded, and this will be available later on. Again, Anthony, thank you very much for the webinar. And we will see you again in the future webinars. Take care, everyone, and have a fantastic weekend.
Thanks. Bye, everyone.
All right, and bye-bye.